So what are the different types of line coding techniques? Since after this quantization, coding is used. So that means it converts the data into binary data, and now this binary data has to be converted into electrical pulses. So line coding actually converts the stream of binary digits into a formal or a code which is more suitable for transmission over a cable or any other medium. So it converts these binary digits into a form which is suitable for transmission over the channel. So, and it is the process of converting binary data into a digital signal. And now let us see what are the characteristics of this line coding. So there are 4 different characteristics: signal level and data level, pulse rate and bit rate, DC component, self-synchronization. The signal level is defined as the number of values allowed in a particular signal is defined as the number of signal levels, number of signal levels. So the number of values allowed in a particular signal is defined as signal levels. So suppose if you consider this particular example, so in this particular case there were 2 levels. So this is one level and this is another level. Suppose if level 1 is 0 volts and level 2 is some 2 volts. Level 1 is 0 volts, level 2 is 2 volts. That means the signal level of this particular signal is 2 levels. And coming to this particular example, so if you see there were 4 different values. Level 1 is like minus 2 volts, level 2 is like minus 1 volt, level 3 is plus 1, level 4 is plus 2. So that means this in this particular signal, the number of values allowed are 4. Therefore, the number of signal levels are 4 in this particular case. So while dealing with these line coding techniques, we have to see what are the number of signal levels and what are the data levels. Okay, so data level means the number of values to represent data is called the number of data levels. So suppose if you consider the binary data that has 2 values, 0 and 1. So if you see this example, so it has each level is, each value is represented by means of either 0 or 1. So this level is represented by 0 and this level is represented by 1. So each value is represented by means of a data level. Therefore, here the number of data levels are 2. Whereas here 2 bits are used. So 2 bits are used to represent each level. That means the 4 different signal levels are represented by means of 4 different levels. So therefore, here the number of data levels are 4. So suppose if you consider the octal number system, so it comprises with 0, 1, 2, 3, 4, 5, 6 and 7. So 7 values it will be having. So which are defined as the data levels. Now pulse rate and bit rate. Pulse rate is defined as the number of pulses per second, and the pulse is defined as the minimum amount of time required to transmit a symbol. Whereas the bit rate is defined as the number of bits per second. If one pulse corresponds to 1 bit, then pulse rate equals to the bit rate. But if the pulse carries more than 1 bit, then pulse rate is lower than bit rate. Therefore, bit rate is equals to pulse rate into multiplied by log L to the base 2, or pulse rate into M, where L is equals to 2 to the power of M, where this M is the number of bits per sample. So this is the relationship between pulse rate and bit rate. And now DC component. So the average of the given signal, average voltage of the given signal is defined as the DC component. So over one cycle period of a waveform, if all the positive voltages are cancelled by negative voltages, then DC component of the waveform is 0. So suppose if you consider this one, so it has both positive polarity and negative polarity. If one cycle period of a waveform comprises with all positive values are cancelled by negative voltages, then the DC component may be 0. So in line coding, the signal with the non-zero DC component is treated as the distorted one, and it can create errors in the received signal. Therefore, the signals with the DC component cannot pass through transformer. Hence, the signal with zero DC components are preferred. So, such type of signals with zero DC components are preferred technique to transmit the data over the channel. So, if you consider this particular example, so everything is represented by means of positive pulses. So therefore, the DC component is not zero. Next one is self-synchronization. This is another characteristic of line coding. So if the receiver bit intervals corresponds exactly to the sender's bit intervals, only then it is possible to receive the signal correctly. That means the clock frequency of transmitter and receiver should be same. So if the clock frequency of the transmitter and receiver are different, then data at transmitter and receiver will be different. So to match data at transmitter and receiver, clock frequency should be same and synchronized. So this is regarding the characteristics of different line coding. Now let us see the different types of line coding techniques. So there are different formats for representing the data coded. So because our objective is to convert this binary data into electrical pulses. So by means of this line coding techniques. So here there are different formats to represent the binary data. So unipolar non-return to 0, polar non-return to 0, bipolar non-return to 0, unipolar return to 0. So here NRZ indicates non-return to 0 and RZ indicates return to 0. And polar return to 0, bipolar return to 0, polar non-return to 0, polar Manchester or split phase, alternate mark inversion codes. So these are the different variations of line coding techniques. So in which in each of these case the binary representation is different. So if you see the unipolar non-return to 0 signaling, here symbol 1 is represented by transmitting a pulse of constant amplitude for duration of symbol, and symbol 0 is represented by switching off the pulse. If you see, symbol 1 is represented by transmitting a pulse of constant amplitude, and where symbol 0 is represented by switching off the pulse. Since it is non-return to 0, so after completion of this pulse duration, it will not come back to the 0 value. It continues. Since 1 and 1, so the pulse is continued here. It will not return back to 0. And the pulse 0 is represented by means of switching off the pulse. So this is the unipolar non-return to 0 signaling. And polar non-return to 0 format. So polar non-return to 0 means here two polarities will be there. Symbol 1 is represented by means of positive amplitudes, and 0 are represented by a pulse of negative amplitude. So that means the symbol 1 and 0 are represented by pulse of equal positive and negative amplitudes. And in this case also, it will not be returned back after completion of the pulse duration. So this is polar non-return to 0 format. It's bipolar non-return to 0. So in the bipolar non-return to 0, a positive and negative pulses of equal amplitude are used alternatively for symbol 1. So a positive and negative pulses of equal amplitude are used to represent the symbol 1 alternatively. That means if you see this binary symbol 1100010110, 1 is represented by means of a positive pulse of a fixed amplitude, and next one is represented by means of a pulse of negative pulse of same amplitude. And if a 1 comes in the next cycle, then it is represented by means of a positive pulse of constant amplitude. So like that it is represented. So a positive and negative pulses of equal amplitude are used alternatively for symbol 1, and no pulse for 0, and no pulse for 0. And this is bipolar non-return to 0 format. Now unipolar return to 0. Unipolar return to 0. So as we have seen, unipolar means 1 is represented by means of positive pulse, 0 is represented by means of switching off the pulse. Whereas in unipolar return to 0, a rectangular pulse of half symbol wide. A rectangular pulse of half symbol wide is used for symbol 1 and no pulse for 0. See, so this is the complete duration of the symbol. But 1 is represented by means of a pulse of half symbol wide. Half symbol wide. And again 1, that means it returns back to 0. It returns back to 0. That's why unipolar return to 0. And 0 is represented by means of no pulse. So this is unipolar return to 0 format. Now polar return to 0 format. So in the polar return to 0 format, symbol 1 and 0 are represented by pulses of half symbol wide of equal positive and negative amplitudes. Equal positive and negative amplitudes. That means symbol 1 is represented by a pulse of a positive pulse of a half symbol wide, and 0 represented by means of a negative pulse of half symbol wide. And 1 is represented by a positive pulse of half symbol wide, and again 1, so a positive pulse of half symbol wide, and 0 is represented by negative pulse of half symbol wide, and so on. So this is polar return to 0 format. Now bipolar return to 0. So in the bipolar return to 0, the positive and negative rectangular pulses of a half symbol wide of equal amplitude are used alternatively for symbol 1. So symbol 1 is alternatively represented by positive pulse and negative pulses of half symbol wide. Half symbol wide. In bipolar non-return to 0, where the ones are represented alternatively by positive and negative pulses of full symbol wide. But here it is half symbol wide. Next one is represented by positive pulse of half symbol wide. And if next one comes, half symbol wide. So this is the bipolar return to 0 format. And this is also defined as alternative Mach inverse coding. And next one is polar Manchester or split phase. Polar Manchester or split phase. So in this one, symbol 1 is represented by positive followed by negative pulse, with both pulse being of equal amplitude and half symbol wide. If you see the 1, so 1 is represented by means of a positive pulse followed by a negative pulse. Positive pulse followed by a negative pulse of half symbol wide, with both pulse being of equal amplitude. And symbol 0 is represented by a negative followed by positive pulse. Symbol 0 is represented by a negative followed by positive pulse of half symbol wide with equal amplitudes. So this is in this way the polar Manchester code or split phase line coding is represented. So the Manchester code is used to suppress the DC component, because it is very important in the digital communication systems that DC component of 0 is treated as the distorted-less transmission. Therefore, Manchester code is used to suppress the DC component and low frequency components. And here the maximum synchronizing capability is included in this particular technique, Polar Manchester code. And alternate mark inversion code. So in this one, as we have seen, so the one is represented by means of a positive pulse of half symbol wide, and when another one comes, it is represented by means of a negative pulse of half symbol wide. So bipolar written to 0 format is also referred as alternate mark inversion code. And the other name for this code is pseudo ternary code. This is also defined as pseudo ternary code because here three different levels are there. Positive, negative and 0. So this code is also defined as pseudo ternary